times geniuses seem to come out of nowhere. Shakespeare, Edison, Newton, Gandhi, Lincoln, and indeed so many others seem to move from total and often rural obscurity to become transformative figures whose impact lasts through the ages. Among geniuses in the Western world, few seem to have traveled farther, both literally and figuratively, and overcome greater obstacles than Marie Curie. Her parents were not scientists. She had no formal university degree. She was not a native speaker in the country where she made her mark. And she was, perhaps the biggest of all handicaps here, a woman. So how did this woman, from basically the middle of nowhere with no obvious advantages, become the only person ever to win 2 Nobel Prizes in 2 different scientific fields? Yes, Marie Curie had a high general intelligence and was very curious. But perhaps more than any other driver of her genius, Marie Curie possessed, call it what you want, passion, drive, motivation, or grit. Passion that manifested in the form of relentless hard work. As you may know, Marie Curie was not born Marie Curie in Paris, but rather Maria Skłodowska in Warsaw, Poland. She became known as Marie Curie after her immigration to France in 1891 and her marriage to Pierre Curie in 1895. Young Maria Skłodowska's first professional interests were literature and sociology, and it took her a bit of time to find her true passion in science around the age of 22. After high school, and to save money, Skłodowska worked as a tutor on a country estate and self-educated so intensely that by the time she was 23, she was able to pass an entrance exam in French to be admitted to the Faculté des Sciences of the Sorbonne to study graduate-level physics. Again, she had no undergraduate degree, was a foreigner, and a woman. One of only 23 women admitted among the Sorbonne's entering class of nearly 2,000 that year. And Curie still had almost no money. As she wrote in her autobiography about her early years in Paris, quote, "The room I lived in was a garret, very cold in winter, for it was insufficiently heated by a small stove, which often lacked coal. In the same room I prepared my meals with the aid of an alcohol lamp and a few kitchen utensils. The meals were often reduced to bread with a cup of chocolate, eggs, or fruit. I had no help in housekeeping, and I myself carried the little coal I used up the 6 flights. This life, painful from certain points of view, had, for all that, a real charm for me. It gave me a very precious sense of liberty and independence." End quote. But Curie's years of satisfying deprivation in the early 1890s were not finished. They were to be followed by nearly a decade of working in what she called the miserable old shed. What Marie Curie meant by the miserable old shed was the laboratory. We saw photos in session 2 that she, the rare woman scientist, was assigned in the left bank of Paris, just south of the Pantheon. The space was more or less a lean-to, more a lean-to than a lab, and had been used earlier as a dissection room by the medical school. Here in this room, lacking proper heating and electricity, and in the adjoining courtyard, Curie first boiled in a large vat an ore called pitchblende, and then separated its components through fractional crystallization to measure the smallest radioactive isotopes. But let's back up here. After arriving in Paris in 1891, Maria Skłodowska first earned a master's degree in physics in 1893 and then one in math the next year, and then started to work on her doctoral dissertation with her future husband, Pierre. The subject of Skłodowska's work was high-frequency rays, how to find them, how to measure them, how to explain them. Earlier, a professor in Paris, Henri Becquerel, had noticed that uranium emitted high-energy rays that could pass through some objects but be stopped by others, as was the case with X-rays. To study pure uranium, uranium had to be extracted from uranium ore. But once the uranium had been extracted from the ore, a substance was left called pitchblende, and Marie discovered it continued to emit rays. If it wasn't uranium, what was generating the rays? So curious, passionate Marie went in search of the minuscule particles, the radioisotopes, hidden inside the pitchblende. Over the years, she crushed, stirred, and boiled down with acid 8 tons of pitchblende, all by hand, ultimately finding therein 2 new elements, which she named, first, polonium, after her native country, and second, radium. Along the way, she coined the term radioactivity. Curie also came to see that radium could kill malignant cells, cancerous cells, and thus began the field of radiation oncology, still used as a primary weapon in oncology today. And her knowledge of high-frequency rays caused her to develop portable X-ray machines that she took onto the battlefield during World War I, machines that could identify the whereabouts of bullets or shrapnel lodged inside wounded soldiers, allowing the surgeons to operate directly on the affected spot rather than amputating an entire leg or arm, for example. But all this started in this miserable old shed, this crushing, boiling, and stirring, and it lasted for more than 4 years. Crush, boil, distill, separate. Crush, boil, distill, separate ad nauseum. Later she recalled, quote, "The heat was suffocating in summer, and the bitter cold of winter was only a little lessened by the iron stove," end quote. Actually, we will see that iron stove in photographs in a moment. In the shed, Curie experienced irritating gases, quote unquote, and radium burns on her hands and fingers that made touching objects thereafter painful. Quote, "Sometimes I had to spend a whole day," she said, "stirring a boiling mass of pitchblende with a heavy iron rod nearly as large as myself," end quote. In this way, Curie gradually reduced the 8 tons of pitchblende, as mentioned, down to somewhat more than 1 gram, a little more than about half an ounce of pure radium. 8 tons for less than an ounce. Talk about passion and perseverance. If you're interested in seeing a modern recreation of the process of extracting radium from pitchblende and the painful labor involved, there's a good video on this on YouTube, and I've listed that for you on the screen. Presumably, boiling pitchblende to find minuscule amounts of radium was not fun. Pierre was ready to quit, but Marie, with Pierre in tow, persevered until his untimely death in 1906. As she later said, quote, "It was in this miserable old shed that we passed the best and happiest years of our life, devoting our entire days to our work," end quote. Passion, happiness, work. Even the second Nobel Prize didn't extinguish Marie Curie's passion. Albert Einstein said of his close friend Marie Curie, the two of them attended conferences together and hiked together in the Alps, that, quote, "Once she, Curie, had recognized that a certain way was a right one, she pursued it without compromise and with extreme tenacity. Passion, perseverance, determination, grit. Now we can add Einstein's term tenacity to the qualities attending passion." But again, passion or obsession? Which was Marie Curie? And what is the difference between them? As we shall see in our session on creative destruction, both artistic and scientific passion are often accompanied by collateral damage to colleagues, to co-workers, and members of the family. Perhaps passion becomes obsession when it becomes harmful to others. Although Marie Curie and Pierre Curie had two daughters, the first of whom went on to win her own Nobel Prize. Curie's daughters were essentially raised not by Marie, but by their paternal grandfather, Pierre's father. Said the younger daughter, Eve, somewhat bitterly about her childhood, quote, "My young years were not happy ones. Marie, her mother, had no time to give to friendship or to love. She loved mathematics and physics," end quote. And then Eve says, quote, "Without the blue-eyed old man," the paternal grandfather again, "our childhood would have been stifled in mourning. He was our playmate and master far more than our mother, who was ever away from home, always kept at the laboratory, of which the name was endlessly rumbling in our ears," end quote. And then Eve says about Marie Curie herself, quote, "Her brain was so precise, her intelligence so marvelously clear, she was supported by a will of iron, by a maniacal taste for perfection, and by an incredible stubbornness. Systematically, patiently, she attained each of the ends she had set for herself." With Marie Curie, passion or obsession may have been a two-edged sword, a boon for science, a bane for her children. Ultimately, Curie's passion killed her. She carried bits of radium around with her in her pockets. Radioactive elements and gases permeated that miserable old shed. Her surviving lab tools remain radioactive today. For amusement, she and Pierre enjoyed sitting around exposed to radium in the dark, entranced by its lava-like luminous effects. We only now know what she helped us to discover. Atomic radiation can kill both malignant and healthy cells. Curie understood some of the pernicious effects of this evil, as she called it, but she took almost no safety precautions until the 1920s. She died of aplastic anemia, a rare disease in which the bone marrow and the blood-generating cells therein have been damaged. Her daughter, Irène Joliot-Curie, similarly died of leukemia. A deadly passion indeed. All right, on to consider our next passionate genius, Thomas Edison.